test. Oh. Hey, everybody. Hello, and thank you for joining us today at Coalesce. My name is Carly Kaufman, and I'm a Director of Solutions Architecture at DBT Labs. My team helps customers determine which version of DBT is the best fit for them. I'll be the MC of the session today. The title of this session is Operational AI for the Modern Data Stack, and we'll be joined by Tristan Zients. Tristan is the co-founder and CEO of Continual.ai. He was previously the CTO for machine learning at Cloudera. Would you believe he grew up without a TV and he didn't learn to read until the 3rd grade? Look at him now. All chat conversations and Q&A will take place in the Coalesce-operational-AI channel of DBT Slack. This allows us the chance to connect with the remote attendees tuning in from all around the world. If you're not part of DBT Community Slack, you have time to join right now. Visit community.getdbt.com and search for Coalesce-operational-AI when you enter the space. If you've already joined the Slack channel, please take a moment to introduce yourself and connect with other community members in Slack. New Orleans attendees, in case you didn't know, we are 30 seconds ahead of the folks watching online, so please refrain from sharing spoilers in the chat. Following the presentation, Tristan will join the Slack channel 1 to 2 hours after the session to answer your questions, but we encourage you to ask questions at any point during the session in the Slack channel. Let's get started. Over to you, Tristan.
All right, thank you so much. I am loud, but I guess that is good. Here's my clicker. All right, so extremely excited to be here. Awesome community. I want to introduce AI and ML to this world of analytics engineering and make the case that we can bring not just AI and ML or predictive analytics, but actual production ML, operational AI to the modern data stack. And we can potentially do it in a new way, a way that respects what we love about the modern data stack, respects about what we love about languages like SQL, respects what we like about tools like DBT, doesn't compromise on governance, but gives us that velocity that the other more famous Tristan talked about yesterday in his keynote. So first of all, who am I? So I've been working in the MLOps or ML tooling ecosystem for the last 10 years. For those of you who were maybe doing notebooks in the 2015-16 era and trying to move them to the cloud, you might remember a small startup called Sense, which I was the co-founder of. It was one of the first enterprise data science, cloud data science platforms. That company was acquired by Cloudera, and I led the machine learning platform team for Cloudera. So some of you might use the Data Science Workbench or Cloudera machine learning product, which is, I did git init on that repository. And I'm currently the co-founder of a company called, a startup called Continual. And you're welcome to come to our booth and check us out and we'll do a bunch of fun stuff as well as just check out what we're doing. But in this talk, I want to talk a little bit about some of the ideas that motivated me to start this startup and just general observations around the modern data stack and the opportunity to bring operational AI to that. So what's the big problem with ML and production ML generally? Well, actually, before doing that, I just want to mea culpa and call myself a hypocrite because a couple years ago, 3 years ago, I'm going to talk about the modern data stack today, but 3 years ago, this was a talk that I gave at KubeCon saying, enterprise machine learning on Kubernetes. So lessons learned and the road ahead, and I basically said, Kubeflow is the answer. Right? And let's just all manage containers and manage our dependencies on containers. And it was a very natural approach. And I spent a bunch of time of my life basically building in this ecosystem. And there's a lot to love about it. But I want to make the case that in this era, in 2022, we should be thinking about sort of the next generation. What does the future look like? And not just what we're doing at Continual, but I would encourage anybody out there, if they're thinking about building your internal platforms or you're thinking about building a startup, let's be more ambitious, right, than this stuff, right? This stuff was, 5 years ago. Let's make operational AI awesome, fun, etc., and not this. So what is this, or what is the state of the art, or the state of the universe today in machine learning operations? Like, this is an analytics engineering conference. If you go to your favorite MLOps conference, which they exist, I think it's hard to not come away with the observation that MLOps is just drowning in complexity. drowning in the way in the complexity that might actually feel surprisingly similar to the way analytics felt like it was drowning in complexity prior to the rise of cloud data warehouses and prior to the rise of awesome tools like dbt. And how do you diagnose that? Well, over the last 5 years, I would say the MLOps ecosystem, and probably a lot of you will feel like this is actually what you're doing internal to your company, have spent basically 5 years copying Uber. So Uber, a number of years ago, released an awesome blog post on their sort of machine learning operations stack, and they said, look, we're doing things like arrival time prediction, right? So we have a business objective that's to predict arrival time. That's what the business needs. And so we're a bunch of super smart engineers. Let's go build a system that's going to allow us to reliably and with low latency predict the arrival times of every single ride and update that, so your phone is up to date. And so what did they build, right? They outlined this stack here. Now, if you look at this stack and you kind of look at the components, you're like, okay, that totally makes sense. There's online component, there's an offline component. But if you look a little closer and you look at each of these components, you're like, that right there is a distributed system called Kafka. That right there is a distributed system called, well, Spark Streaming or Flink. That right there is another distributed system called Cassandra, which is for low latency feature serving. So think about your low latency at scale key value store. That over here, well, real-time prediction service is probably a container service. So it's maybe now on Kubernetes, but it's a container service with an endpoint and service mesh and all this sort of stuff. Then you have a client. That's just your online serving path. You go down here, you have a data lake. Well, I was at Cloudera. That means about 35 different components right there. You're doing data prep, and so that means that Spark, okay, they did put SQL in there. So even in the Hadoop world, right, we had SQL kind of starting to come in with Hive. So we had the Hive feature store, right? So it wasn't this cloud native warehouse, it was on Hive. You had a meta store, you had some security governance layer injected in there as well. Training sets, okay, then you go to batch training. Well, here you probably need a GPU cluster. So I don't know, maybe it's the Kubernetes or maybe it's some on-prem, who knows what it is, but it's a bunch of containers certainly, and now you're worried about, a whole bunch of training needs. Then you have a repository for the actual model version. Again, you have at-scale batch prediction because you have online prediction, so there's Spark. And then you need some sort of monitoring thing, which they were building themselves with Spark. Goes loops around and around and around. So really logical stack. Honestly, it's a great stack. This is a great thing. Look at this stack. It's great. It totally makes sense. If you want to do production real-time machine learning, you need offline data and offline data management for your features, and you need a model training environment. You need online, feature serving so that hey, where's the car right this moment, right? But you also need to know the historical information so you can train models based on the historical information. You need to keep those things in sync, et cetera, et cetera, et cetera. Whew, right? That's a lot, right? If you coming in, you have Snowflake and you have dbt, and then you're like, okay, I want to do an arrival time prediction. I want to do some prediction. And you kind of come in and you go into your, engineering meeting or whatever, and you say, hey, this is what I want to build. It's a lot. It's a lot. It's a lot. So. And I've spent a bunch of time building this, and the question is, what are their alternatives? So you might think that, hey, this is on-prem. We've got the cloud, right? So here's AWS. A lot of things are nice. They're managed, right? Your distributed system is now a managed distributed system. But all of that sort of basic component, right, architecture, the level of abstraction, all of that stayed the same, right? I think anybody this is a sort of a canonical stack diagram for, you wanted to do production machine learning on AWS SageMaker. Again, I would say makes sense, totally makes sense. But God, a lot of components here. You can see, okay, well, here they got their CI/CD here, model registry, model deployment pipeline. All these components. Okay, well, that's the all-in-one, not best of breed. People, we all know that the clouds, they're stretched thin, right? They can't build awesome UIs. So maybe the right thing to do is to look at all the startups, maybe not Continual, but look at all the other startups doing different things in the MLOps ecosystem. And so here, you're left with the MLOps ecosystem. A lot of these tools actually are fantastic, right? There's amazing experiment trackers. There's new monitoring tools, right? There's distributed training tools. There's amazing job systems, the Dagsters, the Prefect of the world, right? Awesome stuff. But still, you're left with that fundamental architecture, right? The level of abstraction really hasn't been raised, right? You're just changing those boxes and renaming them with the latest tools. You're maybe getting rid of a little bit of the management headache, right? If you're in the cloud or if you're using a cloud-managed, startup solution. But fundamentally, those boxes are the same. The level of abstraction has not been raised. So what does this lead to? What's the end result? the end result is really threefold. One, you have infrastructure challenges, right? First of all, you build not only an ML team, but you build an ML platform team, right? That's a very natural thing to do. You got a team of 5 or 6 or 7 people working on building that platform. If you're a bigger company, you got 100 people doing that. The infrastructure and the infrastructure that you're building, unfortunately, and you'll start to realize the friction here, this AI infrastructure, not only is it complicated and expensive, but it's this weird parallel universe from all of your analytics and your business analytics, right? Maybe you managed to put Snowflake or BigQuery in there kind of like to try to unify it, but still the stack, the tools, the workflow, it's these two separate universes, despite that you're probably operating on a lot of the same shared data. The second aspect is just the team. So on one hand, you might just not have enough people to do this work, right? You might not have the skills to do it, although often, when I talk to customers, you actually do have the skills inside the company. It's just that you don't have the time, right? Building the ML platform and then building the model, you have a million ideas of things that you could build, but you're going to only build 1 or 2. You're going to only build the ones that are absolutely mission critical, right? You say, I want to do something that's lighter. I want to have an LTV prediction. I want to have a sales forecast. I want to have something like a little product feature, and you're just going to say, let me go and do something else, right? Change the color of the button, because it's much, much easier. And the final one, which I think is not always appreciated initially, and why people often get started but then kind of move on to the next company, let's be honest, is that ultimately you deploy these things and you're left on the hook managing this wild pipeline that you maybe did get it to production, but it's this wildly complicated pipeline that made sense to you, but because there's no practice, or as somebody told me, I think is in the Austin, there's not only not a practice, there's not a best practice, and I was like, that's a good line. You're just left with this kind of morose, right, if there's not a set of standardized practices. So, and finally, I would say, it's just not that fun, right? You do it once, it's fun. You do it twice, okay, you feel like I'm doing a better job. But after the 5th or 6th time, you're just like, and then, this isn't that fun. And certainly when you start to get paged and somebody says, hey, this prediction is broken, go and debug this other person's pipeline that's a bunch of esoteric code doing who knows what, that's not following the same patterns that you did in your pipelines, it's not as fun, I would say, for most people. So, is this just how things must be? Right? Is this the world, from now till eternity, we're going to live in this world, and that's okay, right? We're professionals, so it's okay. But is there another way? And I want to argue that we've seen this sort of problem, a very similar problem, in other domains, and we've fixed it. Okay? And we fixed it with a common sort of set of ideas. So think about infrastructure, right? A number of years ago, 10 years ago or something, right? We used to manage infrastructure when it was first starting out with a bunch of bash scripts. Let's say cloud infrastructure, right? We got some cloud, we hit some APIs, we spoot these things up, or we point and click in a UI, right? We launch some VMs. Hey, our stack is there, we kind of make it work. Maybe somebody writes some bash to make that easier or bring up a dev. Then we maybe started to try to automate that, and we adopted maybe a tool like Ansible. For those of you who are in there, it kind of has an idempotent workflow, so it kind of brings a little bit of logic to this world. And then we ultimately have ended up in a world where we manage, almost all of us probably manage production infrastructure using tools like Terraform, right? Where you describe what you want, and the system goes and figures out what it needs to do. It looks at the current state of the world, it looks at your desired state of the world, and it figures it out. Kubernetes is another example of that, right? Where you describe what you want, and Kubernetes, through reconciliation, manages it. Pulumi, another one. Completely revolutionized the way we manage infrastructure. Completely reduced the amount of complexity. There's still crazy pipelines and crazy code managing all that stuff behind the scenes. It's not like that hasn't gone away. But for you, the user, you have a very fast path to actually manage your infrastructure that's also governed, reliable, and standardized across your team, where a new person can come to the team and go, oh, I get it, and I'm happy. I'm having a good time. I'm going to build some new stuff. Okay, not just infrastructure. We have the same thing happening in data. So in the world that I come from, big data came along and we was like, let's go. We all got excited about big data. Hadoop was the thing 5 years ago, 5 or 10 years ago. Hadoop was the thing. And then we realized, writing MapReduce jobs, doing all this in Java and code doesn't make sense. We miss the SQL that we used to write. We like the fact that we can do it over massive amounts of data. Is there a way for us to get the kind of benefits of big data, the benefits of heterogeneous data, but also that simplicity of SQL? And so we went to a world of SQL. Well, what is SQL? SQL is a declarative language that's a higher level of abstraction. Behind the scenes, it compiles down to a whole bunch of complicated code execution, right? That's hyper optimized. But you as the end user, again, don't need to know about all that complexity. You can onboard and offboard teams with a standardized set of practices, a standardized skill set, right? That's at a higher level of abstraction that's more closely tied to your business. We're now seeing this even go further, right? This idea of managing data declaratively further. So we have DBT itself, which is saying, hey, let's bring even more software engineering best practices to the world of SQL, right? Let's allow you to kind of like idempotently run these things. So you can run them, you can just think of, hey, here's all my models. I'll sit there and go DBT run, DBT run, DBT run. And the tables will end up as you've defined them inside of your DBT repository. If you're not in the DBT world and you're in the Python world, you can use orchestrators like Dagster and Dagster software-defined assets, shout out Nick right there, to manage all of your assets with this declarative mindset, right? Where you're not thinking necessarily about all these complicated interrelated DAGs, but you're thinking about those individual assets, and you're thinking about that thing that you're trying to materialize, and the system goes and figures out all that complexity. And all of a sudden, you're having more fun, right? You're getting more done, you're having more fun, and you're ultimately delivering things in a much more reliable way, as well as a faster way. And for those of you, just to give you one more analogy, further afield. In UIs, if you're a front-end developer, we used to build things with jQuery. It was like, how do you manipulate websites with like the DOM, which is like, how do you like manipulate things imperatively? And then tools like React came along, which had a declarative viewpoint on how to manage UI. You could define what you wanted from a UI declaratively. That was parameterized by data, but then ultimately it was declaratively realized, and you didn't have to say, well, what exact DOM manipulations do you need to implement to kind of update your UI to the state that you want. Radical simplification of complexity, radical increase in velocity around the ability to get things done, and a beautiful standard, right, that can unify a community to come and work together sort of with a shared set of higher level conceptual ideas. So the solution seems to be, in computing and in these technical domains, to try to find higher level declarative, often declarative, abstractions to hard and difficult concepts. And so the question for me, but I think for all of you, whether you're building internal systems or thinking about the future of ML, is to ask yourself, can we do the same thing for operational AI? Is there a way to bring these ideas of higher level abstractions, of potentially declarative abstractions, to machine learning? And not just machine learning, but to operational machine learning, to production machine learning. Because it is, as I'll show you, actually pretty easy to adopt declarative ideas to machine learning itself. But let's actually go a little bit more ambitious and think about operational machine learning, where we are thinking about the life cycle of managing machine learning models across the development process, staging, deployment, and then ultimately maintenance as the model gets maintained, the predictions get maintained, monitored, governed, et cetera. Okay, so let's think about that. How might we bring some higher level abstraction or declarative ideas to the world of operational AI? So the first thing you have to ask yourself, well, what the heck is operational AI? The natural answer is, the empirical reality is pipelines, right? If you go and look at operational ML systems, they're largely driven by pipelines, running in Dagster, Prefect, Airflow, Kubeflow, et cetera, et cetera, et cetera. And those pipelines do many things. They obviously train models. They generate features. They move features from offline environments to online caches. They deploy models. They retrain models, right? They monitor models, and they monitor models, and they potentially trigger retrainings based on some of the metrics that those things are models, that those monitoring jobs generate. But that's, I would submit to you, the MapReduce of operational AI. That's the low-level reality of what's behind the scene around production ML. So what's a higher level? What are the higher level components? Well, at the very highest, the very center of it is what you could think about as the ML task, okay? Model is such an overloaded word, so you could, I'm going to use the word here, task, the task to be done. And so you think about, okay, let's think, how do we think about ML tasks? So ML tasks, this is an image from a project called Ludwig. It's a code-free deep learning toolbox, but it has a really kind of cool kind of concept. And the recognition is that machine learning is really nothing more than a function that transfers inputs to outputs, okay? It happens to be a function where inside of f of x here, the function between inputs and outputs, there's a ton of parameters that we're going to learn. We're not going to hard code. It's not going to be if and else statements. We're going to learn. We're going to tune those parameters through training to minimize some distance between kind of the predicted outputs and observed outputs, okay, which is the loss, given a set of inputs that go through this function and generate outputs. Now you think, well, no, wait, hold on. There's millions of different machine learning use cases. There's regression, there's classifications, there's text, there's image classification, there's time series forecasting, right? There's all these things. There's, reinforcement learning even. Over the last couple years, there's a general pattern which has been developing that you can model a tremendous number of these simply as inputs and outputs tasks. So for instance, let's think about regression. Regression is typically a categorical variables, number variables, Booleans like true, falses. And a regression means you're going to a continuous variable. So that means that we're over here, right? So you have these types of inputs. You go through some sort of function that you need to learn, and you end out with a number. Okay? Let's say that that would be like linear regression or some tree-based models or whatever the architecture is. That's this, right? But the input, the abstract interface on the top, right, is just inputs and outputs. Think about the case of categories classification. That's the exact same sort of thing with category as your output. Now, maybe you want to actually go a little beyond, and you start to enter the world of like really multimodal data. Maybe you want text in there, right? You have a support case, or you have, I don't know, maybe you even have an image. Conceptually, that's just new input types that need to get encoded into some sort of standardized set of features that need to go through a model, which you're going to learn. You're going to potentially learn these encoders too, and then get decoded. And look, I'm talking in the language of deep learning, but the simple versions of this are if-else statements or linear models or things like that. And just generally just think, hey, it's a function in and out. So those are the standard ones, but there's even more awesome ones, right? Right now, if you're on Twitter, at least if you're on AI Twitter, everybody's having a complete meltdown about a model that goes from text to text, right? Generative AI. The idea that text to text can be things like, English to French. But it can also be crazy things like, who is the president of the United States, right? Joe Biden or something, question answering, right? Or something like that. Or it can even be like, what's the sentiment of this support case right here? And it will just tell you, this support case seems to be pretty positive, right? Or maybe it goes from text to category. And this goes on and on. There's actually things where you can actually frame reinforcement learning as sequence modeling. Of course, you can have time series. So it's an incredibly powerful idea that, hey, inputs and outputs, maybe that's a very high-level concept that we can bring to many, many types of domains. Decouple the use case from the internals. I'm not advocating deep learning or we all position all to one sort of internal model. I'm just saying as an abstract layer here, think of inputs and outputs and then think, hey, maybe we should either select this or automatically select it or something like that. Okay, the second thing is, that's the task. But we're talking about, that's ML or AI, that's not operational AI. The second thing I would say for operational AI is policies. When do we retrain models? When do we promote models? When do we rescore predictions, right? All of these things that we might want to do. And I think there's an argument that, hey, at least for a lot of these things, you can declaratively define them, right? So, this is, in these case of retraining pipelines, it's kind of cron, right? So this is a screenshot from a product Continual where we are using some of these ideas. But what you're seeing here is some of the policies that we define. Once you set up your model, there's some policies that you can define right in the product if you're not going to trigger them with your external orchestrator, where you're saying something like, okay, I want to retrain this model monthly. I want to promote the model, right? So I want to use what do you want to do? Do you want to go manually go in there and look and have a human say promotion? Do you want to take the latest model always because you're pretty confident that retraining makes sense? Or do you want to do a very careful performance comparison where you look at the current model in production, you compare it to the model that you just trained on a standardized test set, and you say, okay, I want to take the model that wins, right? So you're going to retrain nightly, but you might not always promote. Right? So hey, why can't you just sort of declaratively define these, click advanced options for more? Same thing with prediction. If you're in the world of batch prediction, right, where you want to write the predictions back into your data warehouse and enrich those predictions, then say how do you want to do it. So in the world, so how does this apply to, we've basically taken these ideas. I mean, so this is, going into, so what are we doing at Continual? And is this possible to actually realize? At Continual, we're building what we're calling an operational ML platform for the modern data stack. It's really got three key components. One, we're trying to build for the modern data stack. That means, look, data flows into your data warehouse, right? We're not a data integrator. We will connect bidirectionally to your data warehouse. That's where we're going to read features. That's where we're going to read ground truth. That's where we're going to store predictions, okay? In the case of the batch cases. We're going to embrace these ideas of higher level of abstractions, right? We're going to integrate with the tools that are in this ecosystem that have also embraced this, tools like dbt and SQL. And we're not going to fall prey, hopefully, to the gimmicks around AI, where maybe you point and click and you get a good result and it looks super awesome because you uploaded a CSV file and whatever, but you're not going to actually think about the day two, right? The maintenance of the model, the monitoring of the model, the maintenance of the prediction, the features, all of that operational bit of ML. And so I think you need to work back from that if you're thinking about operational ML on the modern data stack. And don't, there's some tools out there that are very easy to connect to Snowflake, and you get a quick result, but have you actually figured out how to operationalize it, monitor, govern it in a way that would give you the confidence to run your business on those predictions? So the way we do this is one of the ways. There's different interfaces. You can do this in our UI. You can do this via YAML file. You can do this in different ways. But one of the things that a lot of this crowd likes about what we do is that we integrate really tightly with dbt. We're not trying to replace dbt as the modeling layer. What we want to say is, look, that task, its inputs, features, its outputs, the targets, that's data that's sitting in your data warehouse, that's modeled with dbt, that's governed with dbt. Let's just add a little bit of metadata here to tell us, our platform, what's what. So in this particular case, I am doing it inside of the actual SQL file, but you could do it in the YAML file if you wanted. Here you have some features around customer activity. You have a customer ID month and some features. What do we need from Continual? We put it in the meta field. And we just say this is a feature set. It means it's not like your target. It's a feature set. It's a collection of features on the entity customer. The index column, the customer ID is customer. The dimension kind of is customer ID. And the time index is month. Time index means we really, in ML, need to take care of time carefully. You don't want data leakage. It's one of the major problems in ML. And so it's like, what did you know about a customer 6 months ago? Because are they going to churn in the future? You have to know their activity 6 months ago so that you can make that, train that model well. So that's a feature set. It goes and gets registered with our feature store, but it's just virtual, right? It's still the data is living inside of your underlying cluster. We then have a model, very similar idea, add metadata, a little bit more here. I've got what my index is, customer ID, time index. I've got the target that I'm trying to predict, which is churn in 1 month. I've got a foreign key reference here to my dimension of my customer, because we're going to automatically bring in all that data. So as you add features about your customers, we're going to know, hey, we need to update this model. And then we're going to add some policies here, train monthly, predict daily. Or if you want to trigger these yourself, go for it, but with our APIs. And then here's the underlying ground truth data and the data that you want to do inference on. All right, what do you get? You get something that looks like this, model and feature set. You do 2 commands, dbt run, continual run. That's it, right? Just with that, that's it. Everything else is automatic. And then the system takes over and tries to do the right thing, right? Tries to build and train a model. And so here you see basically us, change. We have a very kind of tight line between development and production and change management. So here you're saying we did a change of a model. We probably added a feature or added this model to the system. And you're seeing all the steps that we're running. We're creating a number of tables and views inside of your data warehouse to store the predictions. We're profiling this data. We're training models, and we're running a whole bunch of models and getting accuracy on it. We're deciding on whether we should promote the model, given your policies around promotion. And then we're ultimately writing the predictions back into your data warehouse that they're available from dbt, SQL, your BI tools, whatever. We do a ton of stuff. So we have, in this case for regression, we are probably running 11 different type of algorithms. We're trying to be super transparent. You can use the algorithms that are built into the platform, or you can build your own through some of the extensibilities features that we have that do allow you that escape hatch that you sometimes need. Finally, it's not one and done. We then maintain this. So here you're seeing us maintaining your predictions. We've run a whole number of these predictions, every night, probably in this particular case. I've only trained this model once so far. For this demo, this model is accurate, watching the accuracy, how the accuracy is changing over time, when the last prediction is, et cetera, historical performance, monitoring, et cetera. Again, all for free, right? All for free. So let me just end with Continual. We're trying to build, bring and unlock, AI and ML to the modern data stack. If this is like resonates with you a little bit and you think, hey, this is something that you would want to try, stop by our booth, just go to continual.ai, sign up. If you're not and you're just thinking about building your own internal ML systems, I would say be a little bit more ambitious, right? Don't try to kind of just necessarily just create the stack of yesteryear. Try to think about how you can raise the level of abstraction. You're not going to necessarily be able to build the UI that I just showed you, but you definitely can build the level, raise the level of abstraction, allow repeatability and standardization within inside of your use cases. And if you do that, I think you'll empower your whole data team, not just your machine learning engineers, but your data scientists and your analytics engineers. You'll reduce the operational burden of AI and ML, which becomes a lot over time as you have more and more use cases, and you'll accelerate ultimately the business impact from AI and ML, which is obviously what we all ultimately want to deliver. So anyway, thank you. Happy to take some questions after in person and or post on the Slack channel, and we'll check it out in the next hour or two. Thank you.